You are driving on a 6-lane highway. There is no land in front of you. There is no land behind you. There is no land to your left, and there is no land to your right. There is only open ocean in every direction, stretching flat and gray to the horizon, and a ribbon of concrete running straight through the middle of it, carrying you forward at 100 kilometers per hour. You have been driving like this for 20 minutes.
It is pretty incredible.
And then the road begins to tilt downward, not sharply, gently. The way a runway slopes toward a river. Ahead of you, the horizon line starts to rise in your windshield, and the sea, which has been beside you this entire time, begins to climb, and you realize what is about to happen. The highway is going underwater. Not onto a bridge, not onto a ferry. The road you are driving on runs down into the ocean, into a black rectangular mouth carved into a man-made island, and it keeps going, down, under the seabed, for 4 miles. And above you, while you drive, ships the size of city blocks pass overhead, carrying containers from Guangzhou to the rest of the planet, and they never know you are there.
This infrastructure I'm so proud of our nation.
This is the Hong Kong Zhuhai Macau Bridge. 55 kilometers, 34 miles, of road across open sea. It is the longest sea crossing ever built by human beings. It contains the longest underwater road tunnel in the world. It required engineers to manufacture 2 islands out of nothing.
The compacting phase on Island A looks solid. We need to check the bridge connection point.
The wave stress tests are within limits.
In open ocean, in a typhoon zone, because the road had to have somewhere to dive. And when it opened, engineers in America and Europe looked at the drawings and asked the same question that you are probably asking right now. Why would anyone build it this way? Because they had no choice. And the reason they had no choice is one of the strangest engineering problems of the 21st century.
Before we go under the water, I want to know where in the world you are watching this from right now, and what time is it there? Drop your city and your local time in the comments. Now let us talk about why this road had to drown itself.
To understand this crossing, you have to understand the water it crosses. The Pearl River Delta is the single most concentrated manufacturing region on planet Earth. Guangzhou, Shenzhen, Dongguan, Foshan, Zhuhai, Macau, Hong Kong, tens of millions of people and factories packed around one estuary. And everything those factories make has to leave by sea. Which means the water in the middle of that estuary, a stretch called the Lingding-Yang Channel, is one of the busiest shipping corridors that has ever existed. More than 4,000 vessels move through it every single day. Not 4,000 a month, 4,000 a day. Container ships, bulk carriers, tankers, ferries, fishing fleets. Here's a continuous river of steel flowing in and out, 24 hours a day, every day of the year.
Sustaining global demands requires precision. Modern fleets navigate strict industrial channels alongside massive commercial trade, engineering a seamless maritime operation.
Now, here is the problem. On the eastern side of that estuary sits Hong Kong. On the western side sit Zhuhai and Macau. They are roughly 40 kilometers apart across the water, and for decades the only way to move between them was a ferry or a truck route that looped all the way around the top of the delta through Guangzhou.
It leaves a long, foamy wake behind it, making the long transit across the ocean.
3 hours by road, longer in traffic, so the answer seems obvious. Build a bridge. And engineers tried to design one.
The span over the main channel needs another look. We have to ensure the pylon foundations are secure.
Let's review the stress tests.
And they ran directly into a wall. To let those container ships pass underneath, the bridge would have to be enormously tall. We are talking about a deck suspended high enough that a fully loaded post-Panamax vessel can sail beneath it without touching. That is a bridge tower complex reaching hundreds of meters into the sky, in the middle of open water. And that is where the second problem appeared. Because directly above that stretch of water is the approach path for Hong Kong International Airport. That airport sits on Chek Lap Kok, an island on the eastern edge of the estuary, and the airspace over the Lingdingyang Channel falls inside its flight height restriction zone. Aircraft come down through that corridor constantly. Which means there is a hard ceiling on how tall anything in that water is allowed to be. Sit with that for a second.
We only have a 12-meter clearance here.
That is way too tight for the larger cargo ships.
We must raise the flight path ceiling.
The ships underneath require a bridge that is extremely tall. The aircraft overhead forbid a bridge that is extremely tall. Those two requirements do not overlap. There is no height that satisfies both. The problem, as stated, is unsolvable. And there was a third constraint that most videos about this crossing never mention. That estuary is home to a protected population of Chinese white dolphins. Dredging and reclamation on the scale a project like this normally requires would have torn through their habitat.
Heavy marine excavation creates massive plumes of silt. Distressed marine life is forced to flee, threatening the delicate balance of this estuary.
So the engineers were also told, in effect, that they had to build a 55-kilometer sea crossing while disturbing the seabed as little as possible. Impossible height requirements. 4,000 ships a day. A protected species. Typhoon season every summer. Most engineering teams would have walked away from this.
This is impossible. We can't do that.
Instead, the Chinese design team did something that sounds insane until you understand it. They decided that in the middle of the crossing, the road would stop being a bridge. It would become a tunnel. And then, 4 miles later, it would become a bridge again. Why the West never built this? Now, I want to be precise here because a lot of channels overstate this part, and you deserve better. China did not invent the idea of switching between bridge and tunnel in the middle of the sea. Not even close. The United States did it first. In 1964, Virginia opened the Chesapeake Bay Bridge Tunnel.
Today, we bridge the ocean. A modern engineering wonder opens to the world.
A crossing of about 28 kilometers that dips into two tunnels so that naval and commercial ships can pass over the top. American engineers solved this exact category of problem more than 60 years ago. And honestly, it was extraordinary work for its era. Europe did it too. In the year 2000, Denmark and Sweden opened the Øresund link, which runs as a bridge, transitions across an artificial island, and finishes as a tunnel into Copenhagen. Roughly 16 kilometers. Beautiful, elegant engineering. And for 2 decades it was the reference project that every other bridge tunnel team in the world studied. So the concept existed. The West proved it worked. Here is what changed. The Øresund link is 16 kilometers. The Chesapeake crossing is 28. The Hong Kong Zhuhai Macau Bridge is 55 kilometers in deeper water, in a typhoon zone, in a seismic region, over a seabed of soft marine mud, under an active airport approach, through the busiest shipping lane on the planet, next to a protected marine reserve. It is not a different building. It is the same idea taken to a scale where all the old methods stop working. And you have to invent new ones. And that is really the story of Chinese infrastructure in the 21st century, if we are being honest about it. Not usually a brand new concept. A known concept, pushed to a size where it becomes a brand new problem. Which brings us to the part where they had to build land. Building ground where there was none. Here is something that sounds simple and is not. A road cannot dive off the end of a bridge. If your highway is going to descend into a tunnel, the descent has to start somewhere solid. Something has to hold the tunnel mouth open. Something has to carry the ventilation shafts, the emergency systems, the drainage, the fire suppression, the monitoring equipment. On a normal tunnel, that something is the shoreline. Out here, there was no shoreline. There was 40 meters of open water and soft mud. So, before a single piece of tunnel could be placed, the engineers had to manufacture 2 islands in the middle of the sea.
The placement for the first island is locked in.
Let's ensure the second one aligns perfectly with the current.
One at the eastern end of the tunnel, one at the western end. Each one roughly 100,000 square meters of new land. Call it 25 acres apiece, created from nothing. The traditional way to do this is to dump rock and sand until you have a mound rising above the waterline. That method works.
The density charts are holding perfectly.
This core sample confirms it.
The conventional mound is performing exactly as intended. Look at that rock armor, it's completely secure.
It is also slow. It takes years. and it involves dredging and displacing enormous volumes of seabed material, which was exactly what the Dolphin Reserve made unacceptable.
Directly adjacent to the turbid dredging zone, a sensitive marine ecosystem flourishes.
So they used a different method.
But a new era of marine engineering has arrived. Massive cylinders is the future of coastal development.
And this is the part that genuinely deserves the word extraordinary. They built the walls of the islands first. 120 gigantic steel cylinders were fabricated on shore. Each cylinder was 22 meters across, wider than a 4-lane road standing on its end, and the heaviest of them weighed around 513 tons. These cylinders were floated out to the site, held upright over the water, and then driven vertically down into the seabed, not lowered onto it. Driven into it, punching through the soft marine mud to depths of up to 33 meters, using a coordinated group of 8 vibratory hammers firing in sequence. Picture that for a moment. A steel tube, the width of a highway, taller than a 20-story building, being hammered into the floor of the ocean like a fence post. Then another, 120 times, arranged in 2 enormous rings. Once the rings were complete, they formed a watertight wall. The engineers pumped and filled the interiors, and where there had been open ocean, there was now dry. Stable ground with a hard perimeter that typhoon waves could hit without eroding. 2 islands, in months rather than years, in open sea. To put the ambition in perspective, the Boston Big Dig, America's most famous urban megaproject, spent roughly 15 years and around $15 billion burying a highway underneath a city that was already there, on solid ground, with a shoreline.
Boston's Big Dig was the most complex and ambitious highway project in American history, actively rerouting an entire vital artery into a brilliant network of modern tunnels.
This project had to create the ground first, in a shipping lane, in a monsoon zone, before construction of the actual tunnel could begin. And the tunnel is where this gets genuinely difficult. There are 2 ways to build a tunnel underwater. The first is boring. You take a tunnel boring machine, a rotating cutting head the size of a house, and you grind horizontally through the rock beneath the seabed. This is how the Channel Tunnel between Britain and France was built. "38 kilometers of chalk marl drilled through from both sides. It is a magnificent piece of work, and it took 6 years. Boring requires competent rock to grind through.
For the tunnel boring machine to work effectively, we need uniform and competent rock strata. This dense granite is the ideal ground to grind through.
The Pearl River estuary does not have competent rock near the surface. It has soft, saturated marine sediment. Boring through that at this scale, at this depth, was not viable. So they used the second method, immersed tube. And immersed tube is exactly what it sounds like, which is why it is so hard to believe. You do not tunnel under the sea. You build the tunnel on land in pieces in a dry dock. Then you seal each piece, float it out into the ocean, and sink it into a trench you have already dug in the seabed. Then you connect the pieces underwater. Then you bury the whole thing. You are not digging a tunnel. You are assembling one on the ocean floor out of prefabricated furniture. The scale of the pieces is where this stops sounding reasonable. The tunnel is 6.7 kilometers long in total, with roughly 5,664 meters of that being the immersed section on the seabed. It was assembled from 33 separate tunnel elements, plus one final closure joint at the end. Each of those 33 elements was around 180 meters long. That is longer than a Boeing 747.5 laid nose to tail. Each one contained a full dual 3-lane carriageway, plus emergency escape passages running alongside. And each one weighed somewhere in the region of 76 to 80,000 tons. Let that number land. A single section of this tunnel weighs roughly as much as a Nimitz-class aircraft carrier, and they built 33 of them. Every one of those sections had to be sealed at both ends.
Slowly, steady now. Contact made, lock it down.
Floated out into open ocean, towed into position by tugs, and then flooded in a controlled sequence so that it sank at a precisely managed rate onto a trench prepared on the seabed 40 meters below. And here is the part that engineers still talk about. It had to land accurately, within centimeters. Because if a section does not seat correctly against the one before it, the joint does not seal, and a joint that does not seal at that depth is a catastrophic flood in a structure that will eventually carry thousands of cars a day. Now consider the conditions they were doing this in. The tunnel sits at its deepest around 44 meters below sea level, with installation depths past 40 meters. At that depth, in that estuary, there is almost no visibility. The water is full of river silt. The divers and the positioning teams could not see the structure they were placing. They were parking an object the weight of an aircraft carrier in the dark, in a current, in an active shipping lane, to a tolerance of centimeters. 33 times. The final closure joint, the last piece, the one that sealed the tunnel into a single continuous structure, was completed in 2017, and by every account it was the most nerve-wracking single operation of the entire decade-long project. There is no second attempt at a closure joint. The result is the longest immersed road tunnel in the world, and the only deeply buried immersed tunnel of its kind.
Standing by for final alignment. System lock confirmed.
The numbers that do not feel real. Let us step back and look at the whole crossing, because the components are only half the story. The full system runs 55 kilometers, about 34 miles. The main offshore section is 29.6 kilometers, of which 22.9 kilometers is viaduct and 6.7 kilometers is the tunnel. 3 separate cable-stayed bridge sections carry the road over the navigable channels, where ships still need to pass on the surface. The steel, roughly 420,000 tons of steel plate. That is enough steel to build 60 Eiffel Towers. Not 6, 60. plus around 330,000 tons of steel reinforcing bar and about 1 million tons of concrete.
Witness the production of 1 million tons of specialized concrete. Towering silos and precise hydration sprays anchor this colossal precasting gene basin.
The money, roughly 120 billion renminbi for the link, in the range of 15 billion euros, with total project costs including the connecting roads and border facilities, estimated substantially higher again depending on what you count.
The digital twin shows optimal flow through the new inspection plazas.
The time. Construction began in December of 2009. The main works were completed in July of 2017. It opened to traffic on the 24th of October, 2018. Nearly a decade. And the specification that I find most striking of all, the structure was designed for a service life of 120 years. 120 years, in salt water, in a typhoon corridor, in a seismically active region. For comparison, most major sea crossings in the world are designed to a 100-year standard, and plenty of American bridges built in the 1960s are now in urgent need of replacement after 50 or 60. This structure was specified to still be standing and still be carrying traffic in the 22nd century. Whether it actually lasts that long, none of us will be alive to find out. But that was the brief the engineers were handed. The detail almost nobody mentions.
From initial concept to final execution, every calculation demands absolute precision. This bridge stands as a testament to modern engineering.
Now here is my favorite thing about this crossing, and it has nothing to do with tonnage. In Hong Kong, people drive on the left. It is a legacy of British administration, and it never changed after 1997. In mainland China, people drive on the right. So a road that connects Hong Kong to Zhuhai has a problem that no amount of steel solves. Somewhere along those 55 kilometers, every single vehicle has to physically swap which side of the road it is driving on. There is no clever way to do this at speed. You cannot just paint new lines. So, at the boundary crossing facilities, the traffic is routed through a purpose-built interchange that lifts one direction of travel over the other and sets it down on the opposite side. A concrete knot engineered specifically to flip a nation's driving convention. And there is more. Hong Kong and Macau are special administrative regions with their own immigration systems, their own currencies, and their own vehicle licensing. A private car cannot simply drive from Hong Kong to Zhuhai. You need specific permits. Most people who cross do it on the shuttle buses that run continuously between the three boundary facilities. So this is not only the longest sea crossing in the world, it is a piece of infrastructure that had to physically encode a political arrangement into concrete. One country, and in the middle of the ocean, 3 sets of traffic law. I do not think there is another structure on Earth quite like that. What it actually changed. So after a decade, after the islands and the tunnel and the 60 Eiffel Towers of steel, what did it actually do? The headline number is straightforward. The journey between Hong Kong and Zhuhai used to take around 3 hours by road, looping the long way around the delta, or a multi-hour ferry that stops running in bad weather. Now it is roughly 40 to 50 minutes, and it does not care about the weather. That matters more than it sounds. The western side of the Pearl River Delta was historically the poorer, less developed side because it was cut off from Hong Kong's port and Hong Kong's airport by 40 kilometers of water. The crossing was explicitly designed to pull that western side into the same economic zone as the east, the region now marketed as the Greater Bay Area. I will be honest with you about the criticism too, because you can find it easily, and I would rather you heard it here. Traffic volumes in the first years after opening came in well below the original projections. Critics argued the crossing was a political statement as much as an economic one, a physical steel and concrete tie binding Hong Kong and Macau more tightly to the mainland. There are also documented environmental concerns about the impact on the white dolphin population in the estuary, despite the mitigation measures. Those criticisms are real, and a video that pretended otherwise would not be worth your time. But engineering and politics are different questions. Whatever you believe about why it was built, the fact of what was built does not change. 2 islands hammered into the ocean floor out of 120 steel cylinders. 33 aircraft carrier weight tunnel sections parked blind on a seabed 40 meters down. 55 kilometers of road across open sea, threaded underneath an airport's approach path and above a shipping lane carrying 4,000 ships a day. That happened. It is out there right now, and you can drive on it, so let us go back to where we started. You are driving on a 6-lane highway. There is no land in any direction. There is only open ocean and a ribbon of concrete, and the road beginning to tilt downward in front of you. Except now, you know what you are looking at. You know that the road is diving because it was never allowed to climb, that the ships beneath demanded a bridge too tall to build, and the aircraft above forbade it, and the only remaining direction was down. You know that the island you are about to enter did not exist 20 years ago, and that it is held together by a ring of steel tubes hammered 33 meters into the mud beneath your tires. You know that the 4 miles of tunnel ahead of you were built on dry land, in pieces, floated out to sea, and sunk into position in the dark, 1 section at a time, 33 times, by people who got exactly 1 attempt at each one. And you know that above you, while you drive through it, container ships the size of city blocks are passing overhead, carrying the output of the world's largest manufacturing region out to the rest of the planet. And they have absolutely no idea you are down there. That is the Hong Kong Zhuhai Macau Bridge, the longest sea crossing ever built, and the only highway in the world that solves an impossible problem by refusing to stay above the water. If you want to see what China built next, a bridge so high the entire Empire State Building fits underneath it with room to spare. That video is on the screen right now. And tell me in the comments, would you drive it? 55 kilometers of open ocean, 4 miles of it under the seabed. Would you take that road, or would you take the ferry? I will see you in the next one.